In this video, we are going to begin working on solving quadratic equations, and in particular, the method we're going to focus on today is using square roots. So in this video, you're going to learn how to solve a quadratic by isolating and eliminating the squared value, and then we are going to continue to work on simplifying square roots that use imaginary numbers and simplifying those complex expressions where we may have to perform operations with those imaginary numbers. So let's look at the steps here. When you are working to solve a quadratic using the square root method, the first thing you need to do is isolate the exponent. This will always be the first step. Just like in the absolute value unit, when we were solving them, the first thing that we did was we got the quantity that was we were taking the absolute value of on the left-hand side by itself. We're going to do the same thing with the squared quantity. Another important note is that if you are taking an even root, so a square root, a fourth root, a sixth root, you need to, when you take the root, write plus or minus, because that number that we take the square root of, when we do, say, the square root of 9, that could be 3 times 3, or it could be -3 times -3 to get 9. So we have to accommodate for the fact that there's both a positive case and a negative case when we take those even roots. We are only going to use imaginary numbers when we're taking the square root, meaning a root with index 2 of a negative number. And we, again, just like in the absolute value unit, have to check every single one of our solutions to verify. So let's do a bunch of practice problems with this. This first problem says that x squared is equal to 49. Notice here that I have the quantity that's being squared all by itself on the left-hand side. I don't have anything being multiplied or added or subtracted or anything like that. So the isolating is done. That means I can now take the square root of both sides of this equation. When you take the square root of x squared, it gives you just x, because there's one set of x's that come out. And when you take the square root of 49, remember you have a positive and negative case because you're taking an even root. And the square root of 49, that is 7 times 7, which means our answer is x is equal to plus or minus 7. Now to check these, you take this number, positive 7, and then also negative 7, and plug them back into the equation. So if we put positive 7 in there for our check, we get positive 7 squared. That is equal to 49, which is what our equation says, so that checks. I also need to check negative 7 plugged in for the x. Negative 7 squared is negative 7 times negative 7, which is positive 49. So that one also checks. Plus and minus 7 is my final answer. Let's look at the second one now. For this one, you have 2 times x squared is equal to 50. For this one, we first need to isolate. This 2 that's on the outside of the square, it needs to be removed first. So I'm going to divide by 2 on both sides. Those 2's divide out and leave me with my isolated x squared. 50 divided by 2 is 25, and now I can use my square root to simplify. I'm going to take the square root of both sides. When I take the square root of x squared, I'm just going to be left with x. When I take the square root, which is an even root, so I'm going to write plus and minus, when I take that square root of 25, I get 5. So when I check these answers, I'm going to plug both positive 5 and negative 5 back in to the equation. So I'm going to do 2 times whatever 5 squared is, see what that's equal to, and 2 times negative 5 squared, and see what that simplifies to. Now notice how I put my parentheses here. Some of you have been making mistakes with your order of operations, so I wrote these this way so that you could easily see what to do first. For this first one, 2 times 5 squared, you have to do your exponents first here. 5 squared is the first step. 5 squared is 25. So that means I'm doing 2 times 25, which is 50, so the positive case checks. Now in this one down here, I still need to do the square first, but this time I'm squaring the whole x value, -5. So -5 squared is also 25, and that's equal to 50, so this one checks, and my final answer is plus and minus 5. Let's look at a few more examples now. Looking at number 3, do you see what needs to be isolated? Do you see that there's this 3 on the outside? We are not going to distribute it in, no, because there is a square here. This is the same thing as 3 times x minus 5 times x minus 5. You are not going to distribute that in. We're going to divide both sides by that 3, so they divide out. So let's go ahead and do that. We're dividing both sides by 3. They divide out. It leaves me with the quantity x minus 5, quantity squared, is equal to 9. Now I have the quantity that's being squared alone on the left-hand side. So now I get to take the square root of both sides. The square root of a squared number is just the radicand without that square exponent. So I have x minus 5. Now on the other side, when I take the square root of 9, because that's an even root, I'm going to write plus or minus, and then the square root of 9 is 3. So now I need to continue simplifying here. I have this minus 5, so I'm going to add 5 to both sides. And look at what this gives me. I have x is equal to 5 plus or minus 3. I need to solve both of these problems out. When you say plus or minus, that means 5 plus 3 or 5 minus 3. So when we simplify those, 5 plus 3 is 8, and 5 minus 3 is 2. So my solution set that I need to check is 2 and 8. When I need to check, I'm going to go and plug those back in to the original problems. Let's do 2 first. I'm going to do 3 times the quantity 2 minus 5 squared. So to simplify that, I'm going to do 2 minus 5 first. So 2 minus 5 is negative 3. Then I'm going to square the negative 3, so that's 3 times 9. And 3 times 9 is 27, so that one checks. When I plug in the 8, my other solution, simplifying that, 8 minus 5 is 3. 3 squared is 9. And 3 times 9 is 27. So that one also checks, which means my final solution is indeed 2 or 8. Those are what x is equal to. All right, let's look at number 4. Number 4 has a quantity that's being squared on the left, and there's nothing outside of that quantity being squared. There's nothing over here, there's nothing over here, and there's nothing being divided. So that means it is isolated. So we're ready to take the square root of both sides. I'm going to take the square root of the left, and also take the square root of the right. Now, when I take the square root of the left, the square root and the square disappear. That leaves me with x plus 3 on the left. And now look at what you've got on the right. You're taking the square root of negative 64. That's the same thing as the square root of 64 times negative 1. Because we're taking the square root of negative, that means we're going to have an I in our next step here. So you've got x plus 3 is equal to plus or minus, because I'm taking an even square root, and then the square root of 64 is 8. The square root of negative 1, remember, is I, because I is defined as the square root of negative 1. Do you remember what I squared is equal to? It's equal to just negative 1. So again, this very important information from a previous lesson is something we're going to continue to use. All right, so now let's move this over so we can solve for x. We're going to subtract 3 from both sides here. That gives me x is equal to negative 3 plus or minus 8i. Now think about this for a minute. Can you combine this 3 plus and minus 8? You can't, because remember, this I is like a variable when we're doing operations, which means that these are not like terms. I can't do any further simplifying from this point. Now, when you are going to solve these, or to check these, my recommendation, because I is something that's kind of difficult to work with, is that I would plug these into the calculator. Remember, in your calculator, you need to go to mode and put your mode into complex mode, a plus bi. Always check that this mode is set not to real, but to complex, a plus bi, before you start plugging in these problems. So let's give this one a try now. I'm going to plug in this value for x, and put it into just this left-hand side. So I'm going to put parentheses, and then I'm going to put another set of parentheses just around this x value since it's kind of complicated. I'm going to put -3 plus 8, and then I'm going to use my second decimal button to get that I. Notice it's blue on your calculator there. So that's my x. I'm going to put it in parentheses just so I can see it all together nice and easily. Then I've got +3, end parenthesis, and then I have the square that I need to do as well. So I'm going to square that value. When I hit enter, I'm really hoping that's going to give me -64. If it does, that means that is a solution. It does indeed give me -64. Now I've only checked, -3 plus 8i. That solution checks. I still need to check -3 minus 8i. So let's do this again. Now you can type all of this in again, but if you want a shortcut, there's a keystroke you can remember. If you hit second and then enter, do you see in blue where it says entry? That will retype the whole problem there for you. So all you have to do is go back to where that positive 8i is and change it to a negative. If you would prefer to write out or change it to a minus sign. If you would prefer to type this all in again, that's totally fine. Just be sure you do it correctly. When I hit enter, I again, if I want it to check, should get -64. That checks, so that means that this answer is my final answer. X is equal to -3 plus or minus 8i. Okay, let's look at another one here. For this one, we have some more isolating that we need to do. The first thing that you need to do is subtract 4 from both sides. So that gives me 2x squared is equal to 162. And then I need to divide both sides by 2. Then I have x squared is equal to 81. Now from here, I've isolated my square, so I can take the square root of both sides. That gives me x is equal to, don't forget, plus or minus 9. To check my work, I'm going to take that positive and -9 and stick it in there. You can do this by hand, or you can do it in the calculator. I'm going to do this one in the calculator just to again show you some practice, being sure you're plugging things into the calculator correctly. So when I plug in this left side, I've got 2 times positive 9, which is squared. And then outside of those parentheses, I'm going to put my +4. When I hit enter, do I get 166? I do. That means positive 9 works. I can hit second entry to get this copy of what I just typed in, and now I need to put in -9. Now something that I want to point out here is that if I just type a negative right here, it is going to delete this 9, and I don't want it to do that. So I'm going to hit the second button again, and then the delete button has INS, which stands for insert above it. So when I hit second, delete, instead of deleting, it's going to make my cursor flash. And now I can insert a negative sign out front of that 9, so I don't have as much work to do. Now I also want to insert a set of parentheses there, so I'm going to do second insert again and put parentheses around my -9, because really I want that -9 to be the thing that is squared, not just the 9. So be sure you're using your parentheses correctly when you plug these in to your calculator. All right, so when I hit enter, do I get positive 166? I do, so that means then that on my solution set, both of those checked out. Okay, let's look at another one. For this next one, you have this 1/4 out front. If this is 1/4 times x squared, what do you need to do to isolate the x squared? We have to get rid of this 1/4. I'm going to do that by multiplying on both sides by the reciprocal, 4. When you do that, the 4's divide out. That leaves me with x squared is equal to -8. Now I'm ready to take the square root of both sides. So I'm going to take the square root of both sides, and notice at this time we're going to have an imaginary number again because you have a negative that you're taking the square root of. You have x is equal to plus or minus the square root of -8. We're going to have to do a little bit of work with. 8 is 4 times 2, and then you've also got that -1 that you're multiplying in there. So we can take the square root of 4. Let's go ahead and do that. The square root of 4 is 2. This other 2 gets stuck inside of the square root, and the square root of -1 is I. Notice that I wrote that so that all of the things that came out of the square root are on the left and the things remaining in the square root is over on the right. Now let's check your work on both of these. We need to plug into this equation, so I'm going to put parenthesis 1 divided by 4, and then I'm going to multiply that by this quantity squared. So I'm going to put positive 2, and then second period for my I, times the square root. Notice that the square root is in blue above the x squared key, so you're going to hit second and then the x squared to get the square root, 2. And then I need to move to my right to get out of the square root and put that other parenthesis and then square it. So there's a whole lot going on in there. Be sure that what you type in looks just like what I have typed in here. When I hit enter, I get that the answer is -2, and that's what my problem said, so that means the positive version checks out. Now I am going to go to second enter to retype that same problem, and I'm going to use second delete to insert that negative out in front of the 2 because I need to check this negative part of my answer as well. When I hit enter after that, I get -2 again. That checks, which means that both of these answers, plus and minus, 2i times the square root of I, work. Okay, let's do one more of these. Look at this next one. There's a lot of isolating that we're going to have to do first. Which one are you going to do first? Are you going to divide by 2 or subtract 5? You should always do the subtracting of 5 first. Hopefully that's what you just thought to yourself. So let's subtract 5 from both sides. That gives me 2 times the quantity x minus 8 squared is equal to -50. And then I'm going to divide by 2 on both sides. And that leaves me with my isolated square. Notice that there is nothing on the left-hand side outside of this quantity that's being squared. There's stuff inside, that's okay, but there's nothing multiplied out front, nothing added or subtracted on the end. So now I can take the square root of both sides. That on the left is going to get rid of the square root in the square, which leaves me with x minus 8. And on the right side, I've got plus or minus, because I'm taking an even root, a square root, and the square root of -25 is going to be 5i. So let's add 8 to both sides now. Notice here I've got 8 plus or minus 5i. I cannot add together or subtract this 8 and 5 because the 5 has this I with it. These are not like terms. Remember, the I acts like a variable when you are doing operations. So now let's check these two. We're going to have a nice long line to plug in here. I've got 2 times, and then in the x position in parentheses, I'm going to put 8 plus 5i, end parenthesis, and then I'm going to put I'm going to put minus 8. That quantity is going to be squared, and then I'm going to add 5 to it. When I do that, I'm hoping to get -45. I do get -45, which means the positive case checks out. Let's hit second enter, and let's change now that positive sign with the 5i to a minus sign so that I can check my negative case. So I'm going to move my cursor back over, put a minus sign there, and then hit enter. That gave me -45 too, which means that both of these answers check, and my final answer is 8 plus or minus 5i. Okay, so now you may be wondering, we're doing all of this algebra, we're solving for x, what does that have to do with all the graphing that we were doing in the first part of this chapter? So let's look at what that means when we are solving quadratic equations and parabolas versus when we are graphing quadratic equations and parabolas. So let's look at this first problem. X squared minus 9 is equal to 0. If you wanted to solve this algebraically, you first need to isolate the x squared, like we were just doing. So from that problem, x squared minus 9 is equal to 0, I'm going to add 9 to both sides. When I do that, I get x squared is equal to positive 9, and now I can take the square root of both sides. That gives me x is equal to, don't forget, the plus or minus, 3. These, remember, are the x-intercepts, whatever x is equal to. So that means if I were to ignore this algebraic solution that I just did and solve this graphically, I should get the x-intercepts are at positive and negative 3. So let's look at that. This problem is in vertex form because you could write it as y is equal to x squared minus 9, replacing that 0 with the y. And then if I rewrite that just a little bit more so it looks more like that HK vertex form that we're used to, that means that your vertex is at 0, negative 9. So I'm going to go 0 down to negative 9. From there, if I follow the pattern, because my a value is equal to 1, it's the same as the parent function. So I'm going to go over 1 and then up 1 squared, over 2, up 2 squared, which is 1, 2, 3, 1, 2, 3, 4. And I'm going to do the mirror image of it on the other side. If I go over 1, 2, 3 units, that means 3 squared is 9, so I'm going to go all the way up 9 units, which puts me there, and it puts me there. So notice when I draw this parabola that my x-intercepts are just like I was expecting them to be, at positive and minus 3. Okay, let's look at another one. This one's going to have some imaginary numbers in it, and we'll see what that means with the graphing we were doing before. So let's solve it algebraically first. I have x squared plus 9 is equal to 0. We need to subtract 9 from both sides to isolate the x squared value. And then we need to take the square root of both sides. When we take the square root, we get x is equal to, don't forget, plus or minus 3. But then you have this negative inside, the square root of negative 1 is I. So my x-intercepts for this are positive and negative 3i. That means that my x-intercepts are imaginary. Now that sounds kind of bizarre, right? How would an x-intercept ever be an imaginary thing? It's right there on the graph in the previous one. Let's look at graphing this using vertex form again, because that's how our equation is written. We can replace that 0 with y is equal to x squared plus 9. And if I rewrite it so that you can see h and k a little bit more clearly, we've got a vertex of 0, 9, and an a value of positive 1. So graphing that, 0, 9 is there, and the a value of 1 means that it opens up and there's no dilation. So I go over to the right one, and then I rise up 1 squared, so that's just 1. And if I do that, do you see what happens here? It's barely on my graph. If I draw that parabola just there, it's way up high at 9, the absolute minimum. So this means then that it doesn't cross the x-axis anywhere. There's no physical place where it crosses over. And that's why the x's are imaginary. There are no real solutions because it doesn't really actually cross the x-axis. All right, so let's think about this for a second. What are the differences between number 1 and 2, these two problems that we just solved? Number 1, it gave me real solutions, real x-intercepts that on the graph you could graph. Number 2, you got this imaginary number in your solutions, and that's because it didn't cross the x-axis, so it only had imaginary solutions. Number 1 has real solutions, and number 2 has imaginary solutions. Okay, so I would like for you to try the second problem like this, the Now You Try, and we'll talk about it in class. After watching this video, you should be able to solve quadratic equations by isolating and then eliminating the squared value. Then you also should be able to use your simplifying square roots to help with the imaginary numbers, and you should be able to simplify complex expressions by using those operations that we worked on a couple classes ago.